Hello, my name is Lacey Garcia, Geometry and Algebra 2 teacher here at Temple High School. Today we're going to be talking about a concept that comes up a lot in geometry as well as other places such as the SAT. This concept is that of parallel lines cut by transversal. So when we have parallel lines are lines that extend in both directions indefinitely without ever crossing or touching. A transversal is going to be a line that crosses between those two lines. A transversal does not always cross parallel lines. It could cross intersecting lines as well, or lines that will eventually intersect. However, when a transversal crosses parallel lines, special things happen. So notice when a transversal crosses two lines, 8 angles are formed. Angle 1, 2, 3, 4, 5, 6, 7, and 8. There are two categories of angles formed when parallel lines are cut by transversal. You have congruent angles and you have supplementary angles. Congruent angles are angles that are the same size and same shape. The symbol for congruent is the equal sign with a little squiggly line on top. In this example, angles 1, 3, 5, and 7 are all congruent to each other. Also, angles 2, 4, 6, and 8 are all congruent to each other. If a pair is not congruent, then they are going to be supplementary. Supplementary angles are two angles whose sum is 180. Angles 1 and 2 are supplementary. Angles 1 and 8 are supplementary. And angles 3 and 6 are supplementary. There are many more supplementary angles in this, but it would take way too long to try to list them all. Now, if we want to name these angles, there are a few things we need to know. The first is that between the parallel lines is called the interior angles. Angles 3, 4, 5, and 6 are interior angles. When we have angles outside of the parallel lines, they are called exterior angles. Angles 1, 2, 7, and 8 are exterior angles. If you have angles that are on the same side of the transversal, those angles are going to be called co-angles. So we just use the prefix co for those angles. If two angles are on opposite sides of the transversal, those lines are going to be called alternate angles. So angles 2 and 8 in this example would be alternate angles. When we put those together, we have several vocabulary terms that we have. So alternate exterior angles are going to be our lines that are outside the parallel lines and opposite of the transversal. So angles 2 and 8 are alternate angles, and angles 1 and 7 are alternate exterior angles. Our alternate interior angles are going to be angles that are both inside the parallel lines and on opposite sides of the transversal. So angles 4 and 6 are going to be considered alternate interior angles, and angles 3 and 5 are considered alternate interior angles. Our vertical angles are going to be angles that are across the vertex from one another. They're on opposite sides of intersecting lines. Angles 1 and 3 would be an example of our vertical angles, and so would angles 2 and 4. Corresponding angles are a little tricky. These are angles that are in the same position on their respective intersection. So in our top intersection, we have angle 2 in the top left corner of our intersection. And in our bottom intersection, we have angle 6 in our top left corner of our intersection. So because they're in the same respective place on their intersections, they're going to be considered corresponding angles. And corresponding angles are congruent. Other pairs of corresponding angles will be angles 1 and 5, angles 4 and 8, and angles 3 and 7. For our supplementary angles, we have co-exterior angles. So here we're combining our angles on the same side of the transversal with our angles on the outside of the parallel lines. So angles 2 and 7 are considered co-exterior angles, as well as angles 8 and 1. Our co-interior angles are going to be on the same side of the transversal and inside the parallel lines. Angles 4 and 5 are co-interior angles, and angles 3 and 6 are co-interior angles. Our last pair of supplementary angles will be our linear pair. A linear pair are going to be two angles that form a straight line and add up to 180. So our example of our linear pair is going to be angles 5 and 6, angles 7 and 8, angles 5 and 8, angles 6 and 7. And that's just on our bottom intersections. So we won't say the ones on the top, but anytime you have a straight line, you have a linear pair. Thank you for joining me, and I hope you learned something new today.